Alrighty guys, what is up? Welcome back to another episode of The Farmer Was Replaced with Lone Debater 7. And today, we are going to be taking a look at the next set of upgrades. I let the game take over for, I don't know, maybe like 5 minutes, if that. Just so we could get the hay and carrots that we need in order to unlock our variables and our functions. So let's go ahead and do that. We're going to get variables, and we're going to get functions. So let's take a look at variables first, and then we'll take a look at functions. Variables are dynamically typed, like in Python, and can be assigned like this. Basically, name of the variable, you write what name you want, you put 1 equal sign instead of 2, and then you set it to something. You can set it to like a number, you can set it to like a true false, you can set it to measure something, or to like check something, right? And you can store it inside this variable, then you can use this variable later. This is going to store whatever you set it to. So like this a equals 5, if I use this a later, it's going to be the same as if I typed a 5 instead of an a. If I use this b later, it's like I use can harvest in the code, right? Hopefully that makes sense. That's what it's doing. You have the equal operator and the equal operator, right? Equal checks whether two values are equal, returns true false. The equal operator assigns a value. It assigns the value on the right to the name on the left, right? So the order does matter. The name has to be on the left. What you're assigning it to, or what you're assigning to that name, is on the right. Bear that in mind. Okay, that's variables. Pretty easy. We'll take a look at using them in practice in just a moment. Functions, let's look at this. We've already seen built-in functions like harvest. Yes, we have. We talked about that last time. If you missed that episode, there should be a card in the upper right-hand corner of the video at some point, maybe now. That will take you to that episode or to the playlist so you can find it. We talked about built-in functions, but you can define our own functions now using the def keyword or def. Def, name of the function, parentheses, colon, and then you type the code. Pretty easy. Then you can call the function by name with the parentheses, just like you call harvest. Type the name of whatever you define the function as. Same syntax. It'll call whatever you defined in this area of your function. So if you're new to programming, that maybe makes a little sense, but probably a little difficult to visualize. And I get that. It's hard to see things if you don't see them in practice, yeah? Or if you're like me, and that is, I generally like actually getting hands-on and seeing something makes things make a lot more sense for me. Anyway, let's go ahead. I'm just unlocking. I expanded the farm one more tile. I also upped our speed one more time. And this broke our code because this only has 3 X positions, and we now have 4. So that's fine. Let's just clear the whole thing. And we're not using this atrocity anymore. We're now going to actually define some functions. We talked about that in the last episode, that ultimately we want to define a bunch of functions. So today, we're actually going to do that. So what I can do here, I can just minimize this, put it up underneath our unlocks for old time's sake. Actually, I should scroll it and move it like out here, because now it's like it's gone, but it's still there, right? I won't need it. We're going to make something better. So let's start out with MC, or if you're new, and this is the first episode you've seen of the series, move conditional. I do that because I don't want to use the word move, because that's already a function. So def MC. And best practice is really to do this lowercase instead of uppercase. We'll follow that. Colon. Now I can define this. What we're going to do, if our get position y, do I have get world size yet? Available functions. Let's see. Range, plant. I want to say that's unlocked with senses. Get world size. Yeah, we do have it. So we'll show you a variable real quick. So move conditional size equals get underscore world size. Okay. And what that's going to tell you is how wide or how tall it is. So like if I return this right now, it would give me a 3, right? Because 0, 1, 2, 3. Great. So if get position y equals size. So basically, when we call this function, going to assign a variable get world size. If our y is equal to the world size, meaning it's the last tile of our y's, what I want to do is I want to move east, then I want to move north. Else, I just want to move north. Now what does this do? If I go into main, type in MC, and hit this, I can show you what it does. This is just going to simply move us through our land. Whoops. Put this in a loop. Something like this will move us through the whole thing. Whoops. Needs to be capitalized. So it should fire this get world size, but it didn't. Why not? Let's see what that's actually returning real quick. So you can use print, and the drum will... I need debug for that? Okay, we'll unlock debug. We can't. We need hay. Yay. Harvest for... Come on. There you go. Harvest me, like, that much hay. Perfect. Debug. Now, this is useful. We can put, like, markers on the side. Those are breakpoints, so you can execute to that and yada yada. We also get print. Super useful, because then we can, like, test something and see what it does for us. So, print. It's 4. World size is 4. So size should equal get world size. Maybe it doesn't like that variable, so maybe I call it WS. If get position Y equals WS, then move east and north. So the other thing I could do as well, if I just want to watch it in like single step, I can call the function underneath the definition in the same window, and then this will execute it once. So 1, 2, 3. Okay, gets assigned. It doesn't think that it's equal though. Oh, I know what's going on. I need to subtract 1 from this. The world size is counting with normal numbers, so it says this is 4, but in get position Y, this is going to be 3. So if I do WS minus 1, now it'll work. Minus equals move east, move north. Fantabulous. So that's what that does. If I throw back in the while true MC, it'll run us through our little farm. Fantastic. So this is a function. We made it ourselves. Now, when you hover over like harvest, it gives you all this stuff. If you want to get the same thing for your code, like right now it has nothing. If I hit enter and do hashtag, or number sign, if you're a real cool guy, you can add in a comment. And you can actually put these in wherever you want, but if you put it directly above a definition for a function, it'll actually add comments to that note section. So this is used to call the move conditional. Moves through land. Lol. Right? So now if I highlight over this is used to call the move conditional. Moves through land. Lol. Look at that. Fantastic. Now we know what that is. I can delete this out. I don't need it there anymore. So cool. We have our move conditional. I can go ahead and park that like right there. I don't need it expanded. I know what it's doing. We'll keep it expanded because it's not that long. And we don't care about the comment. We know what, like, doesn't matter. It runs without the comment. We've seen that. So cool. Look at that. Now, I wouldn't mind getting trees and doing like a general wood. So maybe what I do instead. So this is going to be our HW for wood in general. Carrots. Nah, this is going to be our everything. Harvest. Harvest everything. Cool. Fantastic. We need some variables here. And these are going to basically store the number of each of the products. So I'm going to have like H equals num items dot. Hey, look at that. I'm going to get like W equals num items dot hey, or dot, not hey, but dot wood, right? C. You just need to be careful when you're using variables, because if you define them in any of your other windows, you could end up breaking your code in an unforeseen way. So just be careful. You should always have unique names for your variables, functions. Everything should have a unique name if you're defining it. Just bear that in mind. We're going to do that. And then move conditional defines its own variable. So that's fine. I am going to put at the top here of variables. Bam. Then while true. What we're going to check is, let's just define like a rec, meaning like requirement, equals, I don't know, maybe, I'm going to say like 50,000. Requirement's 50,000. Sounds like a big number. Whatever. We got this. If it's automated, it's automated, yeah? So if H is less than rec, then we're going to run, what do I want to call it? I guess I could call it like hey. Yeah, we'll call the function hey. We'll run hey. Cool. Elif W is less than rec. We're going to run wood. Elif C less than rec. We're going to run carrot. Fantastic. There we go. Now, I just defined a bunch of things that aren't actually things yet. So, what I need to do here, we're going to change this harvest into hay. Cool. Easy enough. We're going to go def hey, bam, bam, bam. And this is going to be if can harvest, you're going to harvest. Then you're going to run MC, meaning the move conditional. And that's basically it. Do I want it like that? I'm trying to decide if I want this while loop to run this over and over again, or if I want to have this while loop trigger another while loop for this function. You know what I'm saying? Because if I have it trigger another while loop, then I could just call like hey, and it will harvest hay over and over and over. So what I'm looking to do here is actually like harvest a single type of crop. So maybe what makes sense here is clear, boom, boom. If can harvest, harvest, move conditional. And that's probably it, because clear will put it back here. If it can harvest, it'll harvest it, and then it'll move and run this again. Yeah, let's just test that, because this should trigger right away. Ooh, what's happening? Oh, it's running the clear every single time. So yeah, I do need to put this in. So actually, good example. I need to pass our requirement into hey, and this is looking for a requirement. And basically, what we're going to do is we're going to clear it the first time, and then while rec does not equal what am I doing here? No, I need to pass both. So I need to pass the requirement, and I also need to pass our hey. So I need rec, comma h, while our rec does not is greater than or equal. That should work. Greater than or equal to h. Then we're going to do this. Let's try that. Yeah, so that's working the way I want. I'm pretty sure that this is passing the variables the way I want as well. So cool. That'll work. So there's hey. Easy peasy. Lemon squeezy. What do I need to get trees? I need some logs and some carrots. So I guess what we'll do in the meantime is instead of calling wood, we're going to call bush, because I'm going to make a second function called wood that we'll use later instead. Hay doesn't need to be watered. Now for the bushes, I do want to water them, so I'm going to. And harvest bushes. Lol. Okay, great. Def bush. And we're going to clear, because might as well. And we do need to pass in our requirement. And we need our wood. And I need to put these here. Rec, comma W. This should be rec, comma C. We're going to clear it. And then if or while rec is greater than equal to W, if can harvest, you're going to harvest. Then you're going to plant entities dot bush. Then we did unlock watering, yeah? No, we haven't, and I can't yet. Okay, fair enough. We'll add in watering later, just to make my life easy. Water. We'll call it wet. That's the function to water stuff, is wet. So harvest it, plant it, wet it, then after that, you're going to do our MC. Or whether you do this or not, you're going to do the MC. So cool, that's bushes. Dunzo. I need a carrots function. And this also needs the requirement and the carrot number passed. And then this is going to go, sure, we'll clear it again. Doesn't really matter. While rec greater than equal to C, you're going to, if can harvest, there we go. Move that in. If can harvest, then harvest. If get ground type is turf, then you're going to till. If num items check our carrot seeds. Then we're going to trade for carrot seeds. Boom. Then we're going to plant our carrot. Then once we define it or unlock it, we're going to water our carrots. Then, whether that executes or not, we're going to do our move conditional. Okay, so that should be this built out. The only downside to this is this program is going to do first hay to 50,000, then wood, then carrots. It doesn't grow all of them at the same time. So, it's okay, not harvest everything 1 AT. Harvest 1 at time. Because that's what this is doing. Sure. I'm going to make another program that is going to harvest everything. I ended up building something slightly different than what I intended, but it's okay. I ultimately am going to want something like this because this is way more scalable, I believe. But that's okay. We're going to do something like this. This, I do need to pull size. So I can define that as just size equals get world size. And technically in our move conditional, we could pass in size from this function and use that here instead, but it doesn't really matter. So size is going to be size minus 1 is the XY position. And I could actually set that max XY equals size minus 1. Just so I have it, I can call this variable or check this variable if I'm doing like a move conditional thing like this. So that's fine. What I'm going to do, which I'm going to have to do. So let's see. This is going to be while true. What do I want here? Requirements 50,000. That doesn't matter so much. So the only thing is these functions are now looking for a requirement, which is not ideal. This move conditional should be outside of that loop. Otherwise, if it can't harvest, it'll never move. Not what you want. So we'll do something like that. So how do I want to do this? I basically want to check like if get X position mod. Well, I don't really want a moduloso. I'm trying to think of a way to make this scale, if that makes sense. So maybe, I guess I could do a moduloso, because I could have hey mod 1. No, that won't work. Yeah, that won't work. So, okay, we have to do this one by one, which is kind of annoying, but it's okay. If get X position, because I don't have lists yet. Yeah, if get X position equals, yeah, sure, we'll just go one by one. If it's 0, then we're going to run hey, and we're going to pass in. Does it actually matter? It really shouldn't matter. Basically, it'll stop planting stuff if we exceed our maximum. So this actually doesn't matter. So I can pass that through. That's fine. Elif get X position is 1. We're going to do bush rec comma W. Elif get position is 2. Going to run caret with the rec and C. And actually what I'm going to do here, we're going to do carets in the last 2 rows. Or actually, you know what? I want to do hay in 2 rows instead. So we'll do hay in the first and the last row. and then bushes and carrots. Let's try that. Yeah, that's not going to work because this is moving us until it's going to keep running this loop until we hit the requirement. Shoot. I could remove these parameter requests. Yeah. Actually, undo that. Can I just like comment them? Oh, yeah, I totally can. Okay, sick. We'll do that. Then can do the same with this. And I actually need to do that not there, but in front of the while, because I don't need a loop anymore. Then is that gonna yell at me? Oh, I forgot the colon here. Fair enough. Too much indentation. Yeah, I was kind of afraid of that, so fine. We'll just do something like this. That way I can uncomment these if I switch over to one at a time later. And I kind of need to do that for the rest of them, huh? Shoot. Okay, fair enough. That one's fine. Bush needs to be commented. Okay, that should work. Oh, I also need to pull those out of here, because it's going to try to pass something it's not expecting. There we go. Why is this not working? Because it's calling the clear every time. Okay. I guess I don't really need the clear. Actually, yeah. Let's pull the clear out of all of these and put that inside of the main before it calls. So like, actually it doesn't matter. Doesn't matter. We don't need the clears. Let's just go. Why is it not triggering this? I might have to type get exposition a second time here. I was hoping it would let me just do it slightly, but it doesn't look like it. Why not? Syntax again. Got me twice on that one. Darn it. Okay. Good enough. Yes. Now it's going to have to go around to plant those carrots, but that's okay. Why didn't it plant? Oh, because the plant's inside the if can harvest. Shoot. This should also be out. 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 Troubleshooting 101. It kind of works. Can you make it actually work? Yes, is the answer. This also has to move outside of the thingy. And actually, honestly, nothing should be under that. Like, I messed that code up, is what happened. Alright, there we go. It seems to be working, sort of. Maybe, kind of. So we need gold for these. We can almost get trees. We could get watering. I think we grab watering. So I can get water, I can trade tanks. and I can use tanks. All right, let's kind of make a water function. And we already decided we're going to call this wet. If you become a member or drop a super on any of the videos in this series, I will name, a function after you if you want. So yeah, just FYI. But for now, this one is wet. Makes the ground so moist. That's exactly what this is going to do. So basically, all this is going to do is if our num items of items dot empty tanks is less than 100, then you're going to trade items dot meant empty tank. So trade items and empty tank. That'll maybe work. I don't have multi-trade, right? No, still locked. I need 300 carrots. I'm not going to worry about it. So basically the way this works, empty tanks slowly refill over time. So yeah, but I need to buy more than one tank is the issue here, I think. So actually, let me get some variables. Diff or wdiff equals, and actually let's just do this. WT ET. So water tank is num items dot water tank. ET is num items dot empty tank. Then wdiff is what do I want this to be? The difference between our it's going to be our empty tanks minus our full tanks? No. Yes? Maybe. Empty tanks less than 1. Yeah, no. It is going to be this. So if empty tanks are less than 100, right, we want to trade for more tanks. Basically, our W difference is going to be the difference between our water tanks, so our full tanks, and our empty tanks. So, no, vice versa. It's our empty tanks minus our full tanks. So, ET minus WT. And what we're going to do is while while our full tanks is less than nah, we don't need to worry about this. You know what? It's okay. Once we get multi-trade, then we can utilize this. It's really going to be ET minus. Actually, it's ET plus our water tanks because and this is going to be T total tanks because your water tanks become empty tanks and vice versa. So if num items empty tank is less than 100, trade that. And I guess I could use this as a blanket rule. If I always have 100 tanks, we should be generating 4 water a second, which is more than enough to keep everything watered. So do I want to keep this? Sure. We'll use the variable, though. The other thing we're going to do, if T underscore tote is less than, I don't know, what do I want to set the upper limit for? Maybe like 1,000? Sure. It costs wood is the only thing. So this is going to spend all my wood. So maybe I want to be a little more conservative. We'll just go 500. Then we're going to trade... You know what? I'm making this more complicated than it needs to be. Don't need to. If we have less than 100 empty tanks, we're going to buy an empty tank. Sure. Then if get water... This measures how much water is in there. Is less than 1. We're going to use an item, and we're going to use a water items.water tank. And it's actually not... It's actually while get water is less than 1. We're going to use water tanks, because what this is doing... We're going to keep using water tanks until we hit full watering, then we're going to move. And then we're going to exit the loop. That's all this is doing. It's buying the tanks and then using the tanks. That's it. It has this checked mainly so we can do this. And frankly, I should probably nest this loop inside of if w underscore t is greater than 0 loop, or not loop, but conditional check, just because you can only use an item water tank if you have an item water tank, and frankly, it needs to be 4 tanks, because if it's a 0 water tile, it'll take 4 water tanks in order to fill it. So we need to do that. Now, what we can do is remove the wet calls from all of our functions and restart. So we're slowly getting more tanks. Eventually, these will convert over to water tanks. See? So now we have a water tank, and we have empty tanks. Cool. So yeah, we are burning through our wood right now. So what actually would make sense is to switch these and do more bushes and do less hay. Okay, cool. Eventually we can unlock trees, which would be helpful. That will aid our wood scenario that we're dealing with. We could increase our speed, sure. Increase our yield on grass, because we can afford it. We could get multi-trade. Let's actually do multi-trade real quick. And then we're going to stop. And then what I'm going to do here, it basically multi-trade just adds a modifier. You can put the number of items. So empty tank, comma, E max is what we're going to call it for empty tank max. This is going to be equal to ET trade is going to be equal to 100 minus E underscore T, because I want to have 100 tanks, empty tanks on hand at any time. If we're less than that, we want to buy up to 100. So we're going to go E underscore T underscore trade. And that'll do that. Now, granted, we're not going to have the wood to buy this, so not quite going to work, but... Or it's going to be mad at us, is what's going to happen, but that's okay. This might balance out, I don't know. I guess if I wanted to make this more conservative, I could put T-tote in here, meaning our total number of tanks is 100 minus our total number of tanks instead of just our empty tanks. And I could do something like that, but it's okay. And the soil does stay, like if I tilled this and then planted the bushes, the soil would stay watered a lot longer, I think. I don't know how long turf, I know soil holds water better than turf. Or it's more like you can visually see it as it dries out, I guess. But yeah, anyway, we're running. It's fine. Basically, at this point, I just need to wait and unlock some more stuff. I can actually get trees now, so fantastic. Basically, trees are the same as bushes, except if they are growing next to another tree, they will grow slower. So basically, in order to grow trees optimally, you need to checkerboard them. So, now that we have trees, let's do one last function to grow them. And then we'll end the episode there, I think. So, cool. Def. Or actually, trees and bushes. We're going to call it wood. So for def wood, let's see. What do we need? Where's our bushes? If can harvest. It's true. We're going to harvest. Boom, boom. Then we need to check our XY position. So basically, we have to alternate what X we plant on based off what Y we're on is what we need to do. So like, what I mean by that is, if I'm in Y, or if I'm in X0, I have to plant either on Y0, Y3, or Y1 and Y4. Right? So that's kind of what needs to happen. So what I could do here is, so if I do the divisible by 2, that would work again. So like, if get position X, but I think I actually want to get position Y, modulo 2 is 0. So that's just going to plant on the even number zeros. I also need to do this. So to make this fully modular, I need to do it this way. If get X position mod 2 again equals 0, then if this Y position mod 2 is 0, we're going to plant entities.tree. We're going to run wet. And we're going to run MC. Or actually, that's going to go at the bottom. Elif, or can I use just an else? I should probably do an elif just to be safe. Get pause Y mod 2 does not equal 0. Then we're going to plant entities.bush. We're going to run wet. I'm going to move this up just so we can see what's going on. Okay, cool. Elif get position X mod 2 does not equal 0. Then I want to do the opposite of these. So just put knots. Perfect. And that should work. Now what this is going to do is it's going to checkerboard plant trees and bushes. So we'll get way more wood running this. So for this one, I do want a rec and I want a W. And we're going to loop. I am going to build the requirements off of this one, and I'm going to change this to wood is what I'm going to do. And then what I could do, I'd like to run this now is what I'd like to do. Because I really need wood is kind of my limiting factor. So I think what I'll do, we'll just call it here. Because this has its own while loop, so... Oh, it's going to be mad that we don't have requirement in W defined. Shoot. Okay, fine. I'm going to take these out eventually, but it's not a big deal. Num, items, wood. Okay, this should work. Oh, these have to be outside. Meaning, I have to define them here. There we go. It's trying to water. Oh, I forgot to put in the move conditional. What a dummy. There we go. So as you can see, we have a checkerboard pattern of trees and bushes, so we should get quite a bit more wood. We also, by getting trees, we can now increase the yield of our trees and bushes a few times, so we'll get a lot more wood. And I think I'm going to let this run for a little bit, mainly until I get all of the empty tanks that I'm looking for. Because I would like to, kind of not need to spend wood on tanks. Anyway, guys, I think we're going to wrap it up here for today. In today's episode, we did talk about quite a bit. We talked about variables. We talked about functions. We unlocked a bunch of stuff. We built a bunch of new functions. We revamped a bunch of things. We have the ability to harvest up to a requirement, one item at a time. Also have the ability to harvest everything at once. So pretty cool. And we can toggle between them depending on what we want to do. We can also run each of these individually if we so wish. We also, have watering unlocked. Pretty cool. In the next episode, I think what we're going to look at, we could dive into pumpkins. I think we'll do pumpkins next. Yeah, we'll probably do pumpkins. Then we'll maybe look at sunflowers. Sunflowers are a lot harder than pumpkins, is why I say that. Utilities I don't need yet. This is useful for sunflowers, kind of, maybe. Getting the rest of this stuff, yeah. I think we'll get pumpkins next, because once we have pumpkins, so hay, wood, carrots, and pumpkins, unlocks all of the, programming stuff. Meaning, like lists and dictionaries. Well, dictionaries, I guess, takes gold. So those are locked behind mazes. But that's fine. We can get up to this point though, right? So we can get most of our stuff. The only thing we won't have is dictionaries, but to get to dictionaries, we need pumpkins and carrots. So I think going pumpkins next makes the most sense. So that's what I'm going to do. I am going to bump up the efficiency of our carrots since we have the wood and it's not too expensive. Just so when we plant carrots again, we end up harvesting a lot more. Anyway, guys, if you enjoyed the episode, be sure to like, comment, subscribe as always. And until next time, this has been Lone Debater 7, and we will see ya.